As mentioned earlier, you can see my video is also switched off because of bandwidth in my area. So sorry for that from my side. As mentioned here, we basically our presentations on the documents that was available on social media since last week. Therefore, I will also start an idea to hypothesis in 5 easy steps. Now, my colleagues completed step 3 this afternoon, step 4 this afternoon, and I am specifically going to look at step 5, where we need to look at state your aim, hypothesis, engineering goal, etc. So now that the learner sort of already identified his research problem, is now ready, as Mubata mentioned, ready to write an aim, a research question, hypothesis, engineering goal, design goal, algorithms. As we follow, or as we progress throughout this afternoon, I will reflect back to certain things that happened in the past as well. So already was mentioned that document 2 can be applied to any type of project. I will actually still use the one with the example of the food, starting with a mind map where you basically have to brainstorm ideas around food, and after you sort of have that ideas looking at food allergies, etc., narrow it further down so that you can basically particular document. Now, this slide basically will focus on, I will start with alternative ingredients, but I will also later on look at transportation of food. So when we look at, we need to go ahead. We started maybe with the categories, the learner know which category, but now we've got the 4 different types of projects that the learners will be able to participate in. The scientific investigation project, engineering and computer science, mathematics, theoretical, and then social sciences. This afternoon, the presentation will basically be around the scientific investigation, where we looked at alternative ingredients from the previous slide. Engineering type projects, where we look at the transportation of foods in that particular area. Later on, when we share all these documents, we will try our best to share computer, mathematics, and all the other types of writing style for each one at a later stage when we share the documents. So let me start with the scientific investigation. To write an aim. So now we've got the focus of our research, which will basically guide me to drive me to really, I know now what I really want to investigate, what I want to achieve, what I want. That is basically my starting point. But to write the aim, there's a few ideas of how to write your aim for your research. For example, to determine if, to find out if, to compare, to explore, just 4 ideas of how to write. So if we look at the example, for instance, of the aim for this particular research, remember scientific food again, to find out which type of food or ingredients can substitute or be used as an alternative to gluten to make flour. So I use the example to start basically my aim with to find out, just to guide, listen, this is what I will go, or how I will go forward with this idea. So now, after I'm done with my aim, I can now go and move towards my research question. So, to rewrite the problem as a research question, it is important that we need to know that, or remember, that questioning is probably the most important part of any scientific inquiry, because it enables us to formulate research questions. It also allows us to consider the reasons why you want to investigate these problems. So, therefore, your research question must not have a yes-no answer. That's the first one. And to guide us to write the research question, we can use the 4 wives and the 1 husband strategy or idea, where, sorry for that, where we use the why, the when, the which, and the what, but also the how to formulate my research question. When we're done with the first research question, and we must encourage learners that you write the first one, you write your second research, and you keep on improving on it. But eventually you must ask yourself, is my question testable, doable, or practical? So some learners, practicality is sometimes a challenge, and then when they get closer to Expo, now suddenly they need to change. Do you have the required time if you look at your question? Do you have the required resources if you look at your question? So this is the kind of things that the learner needs to take in consideration. But for a learner to really be strong, or to really have a very good research question, a strong research question, they need to know it can be a simple one, but it must be clear. So if they start with the why, the when, the which, and the how, that is sort of already an idea of where they're heading. So an example, then you can use your own examples as we continue. I use the which, for instance. Which grains could replace gluten to make nutritious flour? Which vegetables could replace gluten to make nutritious flour? But if we can combine the two, are grains such as rice or vegetables such as potatoes more suitable for replacing gluten in flour for diabetics? So when we look at it, that is just examples of research questions. If you look at the questions, I've sort of bolded a few words as well. The grains, nutritious flour. Vegetables, nutritious flour. So at the later stage, as we move on, you will later on realize why I sort of highlighted the words in this research question already. So now that you have an idea of how to write a research question, I think it is basically time to recap quickly that your research question needs to be strong, it needs to be simple, but it needs to be clear to move forward. So to move forward, we can look at the hypothesis. Now, the question is, what is an hypothesis? The hypothesis statement is basically a guess, a prediction, or a hunch we make in order to investigate, to test whether the hypothesis can be accepted or rejected, or whether it is correct or incorrect. And sometimes learners don't want their hypothesis to be incorrect, and you must let them understand it can be incorrect up at this stage. The hypothesis also, it must be clear as the research question. It must be simple, and it can be testable as well. or it must be testable. But to have a clear and simple hypothesis, it is important that you need to identify variables. You need to be clear with regard to your independent variable, your dependent variable, and the control. Just to stop a little bit, the independent variable, please make sure that the learners understand the independent variable. I normally use the I. The I in independent variable is the change that I make in this process, or basically it is the cause in this experiment. The dependent variable will basically be the effect of this. And when we look at the control, it is important that the learners know the controls for the different or for the experiment as well. So when they write the hypothesis, again, a guideline. So say, for instance, they start with if, make the statement, then follow it with a result. Or they can start with suppose, their statement, then the result. Easy, clear, simple, but everybody can see what they want to achieve in their hypothesis. An example of an hypothesis. Gluten-free flour from rice has less glycemic carbohydrate per 100 gram serving than flour made from potatoes. Again, I highlighted a few words because I want you to, before I move on, try to see if you can identify the independent and the dependent variables for this scenario. Remember, we're still busy with a scientific experiment or scientific project. So gluten-free flour, I highlighted rice, and I highlighted potato. So my suggestion, I hope you will agree with me on this one. For me, the gluten-free flour made from rice and also the gluten-free flour made from potatoes. That is the independent variable for me, because it's what I determine, what the cause that I have. But the glycemic carbohydrate, that will be the dependent variable, the effect that I have. But it is important that per 100 grams serving is the control. Now, that is just as an example to differ between the independent, dependent, and your control variable. Please encourage learners to make sure during the experiments that they are aware and list all control variables, because sometimes they just do one or two and think that that is enough. But encourage them to make sure that they sort of have all the possible control variables already mentioned. So at this stage, this is what we've got with regard to the hypothesis. And please, at this stage, we don't know whether it is true, whether it is false. Only the following, the method, the experiments will actually bring me back. So if a learner finds something different, that is good. So this is basically up to where your scientific project runs. The research question and the hypothesis. So when we look at the engineering, we need to define a need. Now, I'm not going to stand very long with this because Mabatu emphasized it already. We need to look at who needs what, because why. So when we try to write a need, again, to build a what? that can, why, for, who. So if the learners focus on those three things, it will guide them basically to identify their need: the who, the what, the why. Earlier, I mentioned about my example, transportation of food. So in this case, the who will be the farmers. What do they, what? Special temperature controlled vehicle. Why do they need it? To transport food. So just simple, but very specifically with regard to who, what, and why is involved. So when we look at the following or the next one, which is your engineering goal, it is important that the requirements for the design needs, you list them. So again, the same one on the previous slide, just differently. Say what, for who, in a world where, and that is my why. So as an example, the design construction of a cost-effective solar-powered temperature-controlled vehicle, that is what I'm going to build. Sorry. For farmers, which is my users, to transport bananas, which is my function, my why. So simple, but clear with regard to the what, the who, and the why that we need to look at. So when we continue with engineering project, design criteria is also important. The learner needs to identify the design criteria and design constraints while they're busy with their engineering goal. The design criteria, example, for instance, they need to look at size, 1 ton capacity, for instance. They need to look at functionality, 13 degrees Celsius, air circulation, 50 movable shelves. It must be solar powered, for instance. But also, they need to look at design constraints, cost effectiveness, energy consumption. So when we look at that, that is basically when we do our engineering process, where engineering type of project, how we can move from your need, your engineering goal, but take in consideration your design criteria. So in conclusion, I normally say, using the science research process, it is very important, and we need to make sure that the learners also understand it. As scientists, we try to understand how nature works. As engineers, we create things that never were there. So that is why we take them through this whole process. In closing, to remind you, the process is generic. The 5 basic steps described in the pyramid can be applied to any type of project or problem, but it's also important that the learners must understand, as Shaw mentioned, the literature review is so important, and they need to continue with that literature review. Record all planning in the dated journal or diary. It's important that the journal is complete. But while they're at this stage, at this step, they need to think about materials and methods they will use, but also need to take in consideration ethics and safety. And ethics and safety will be handled at the next session, next video or Zoom conference on the 22nd of April. I thank you.
Thank you so much, Lyndon.